Hi, I am Varun Joshi and welcome to day 23 of our Certified Kubernetes Administrator 2025 course. Today, we are diving deep into a must-know concept for Kubernetes administrators, which is Kubernetes Health Probes. By the end of this lecture, you should have a clear understanding of what are liveness, readiness, and startup probes and how to use them in production grade environments. First, let's answer why do we need health probes? As administrator or as a developer, you would want that only healthy pods should receive traffic and pods that are stuck in a deadlock must be restarted. Lastly, you should ensure that pods have enough time to start the application. Now, before I discuss anything else in this diagram, let me tell you one quick thing. If let's say a pod has two containers, the pod will have the status of running only when all the containers in the pod are running fine. If any of these containers has any error, then the status of the pod will represent the error state of the container. For example, if there are 10 containers in a pod, let's say, if 9 are working fine, but one of the container is in error state, then if you run kubectl get pods, then the status of the pod will represent the error that 10th container is facing. So if I go to my Visual Studio Code, you see that I have a normal pod YAML. I am creating two containers here. One is Nginx container, which uses Nginx image and the name is also Nginx. Then container 2 has the name of supporter, and the image part I have written some gibberish here. So if I go to my terminal and if I apply this YAML kubectl apply -f, I've called this test.yaml and it says the pod is created. If I now run kubectl get pods, just allow it some time, it says container creating, it says error image pull, and we know that it is not able to pull this image, which is why it is throwing this error. One container is ready, that is our Nginx container, but there are two containers and the second container is not in the running state. Hence, this represents the error state of the worst container in your pod. This only had one container and that container is running, hence the status is running. Now let's go back to our diagrams. So we know that to ensure that our application is healthy and continues to be healthy as long as it is in the Kubernetes cluster, then we want some sort of mechanism which will ensure that if application has a deadlock or application is in hung state or if there is a temporary error, then Kubernetes should take some action, and that is where health probes come into picture. They help us solve all these three problems. If I scroll down, you see health probes here. First type of health probe is readiness probes. Like we discussed above, only healthy pods should receive traffic, and readiness probes ensure that. So for example, if you have a single container and you define a health probe for that, I am saying you define the health probe for a container. So if you have 3 containers, you can define health probe for all those 3 containers. And what kind of health probes can you define? You can define all the health probe for every container in the pod. Now, would you want to do that? I'll leave that up to you because that is application specific. In this pod, I have 2 containers. I can define health probes for both of these containers. Okay, so let's get back here. Readiness probes ensure only healthy pods receive traffic. If somehow this pod is not responding well to the readiness probe, then this pod will be taken out of the load balancing or this pod will not receive any traffic. That is what readiness probe will do. Second is liveness probe. Ensures pods stuck in deadlock must be restarted. We have 2 containers here. If we have defined health probes for only one container and that health probe is liveness probe. And if application running on this container is in hung state or is in irrecoverable state, then liveness probe will restart that container. Third is startup probes. Startup probes will also restart the application, but they have a special use case. You will use startup probes for application that starts slowly, that takes some time to initialize. Hence, you would use startup probes so that pods have enough time to start the application. One key point, probing only works once the container is in running state, which makes sense. If the application has never been in the running state, then how will you monitor that application? So once the status of the container is running, only then probing will start working. If I go to this terminal again, then you see that one of the container is in error image pull state. If the container is in this state, how do I monitor that container? So the container must first be in running state, and when all the containers part of a pod are in the running state, only then this status will be running. Let's get back to the diagram. Kubelet performs probing. As you know, kubelet runs on each worker node and also control plane node, and kubelet ensures the health of the containers and it reports that health to the API server. It reports the health for both nodes and pods. Kubelet is the one that performs these probings. So what you do is you define your probes within a container, and then kubelet is the one that performs the probes. Now let's take a deep dive into each type of probing. Health probes, they are of three types. First is readiness, liveness, and then you have startup. Readiness probes checks if container is ready. Now if you go here, the pod has a ready status as well, and this says there is a single container and then that container is in ready state. This says there are two containers in this pod and only one is in ready state. Now in case a readiness probe fails, you will see that if, let's say, we had defined a readiness probe for this container and that failed, this one will change to 0 because that one container has failed the readiness probe. Hence, the status will be not ready. What does not ready imply? Not ready implies the pod will not receive any active traffic. But Varun, what will happen if my pod has two containers? I have defined probes for both of those containers and only one container failed the readiness probe. What will happen? Will my pod not receive traffic? You are correct. Even though if one container failed the health check, the probing, none of the containers part of that pod will receive any traffic because the pod itself is given the not ready status. So this is a critical point to understand. Second is marks pod unready on failure. We have seen this. Ensures only ready pods serve requests. We want that pods that are healthy should only serve the request. Runs continuously throughout the pod's life cycle. Like I said, if you have mentioned readiness probe for a container, then that probe will be monitoring that container till its lifetime. As soon as it comes in the running state, your readiness probe will start monitoring that container. Use cases: DB connection initialization. For example, you have defined that my readiness probe will only succeed if I can, let's say, check my container on a specific port. This can get a little confusing. So what I'll do is I'll quickly scroll down, I'll just show this to you in Visual Studio Code. So I'm opening a readiness probe YAML just to give you a basic understanding. So what we are doing here is we are defining a readiness probe firstly within a container itself. Hence, if I am saying the readiness probe in this example to cat a certain file, it will cat that file in the main container itself, in the container itself. So this is a very nuanced point. It is not going somewhere else to perform this. We are saying run this command in this container itself. So when I say use case is DB connection initialization, then my readiness probe will check that there is some file or something available in the container which says that DB connection is working fine. And if the DB connection is not working fine, then I do not want that container to be in ready state. I want that container out of serving traffic. That is exactly what we are discussing in this use case. Second could be application initialization. Last one is temporary overload. Why we are using the word temporary? So for example, let's say you are running a Node.js application and there was a glitch in that application. Would you want to restart that container, or would you want to allow some time for that container to recover? Because restarting is hard. You do not want to restart your application pods unnecessarily. If the pod, let's say, will come out of that situation in a second or two, then you want to avoid that. You want to make that container not ready, and then once that problem is solved, you can make that container ready again. This is where readiness probes come into picture. So for example, if you are asking, we'll discuss probing mechanism in a little while, but right now let's say that a readiness probe is checking that there must be a file in the main container in a specific location. If that file exists, then my container is working fine. Maybe for some reason that file was inaccessible, and after 2-3 seconds the file got accessible. Then you do not want to restart that pod. That's a temporary glitch. Maybe that temporary glitch was because of overutilization of resources or XYZ reason, but we do not want to restart that container. Hence you would use readiness probe in such situations, because readiness probes do not restart your pod. A very critical distinction from liveness and startup probe. Readiness probe will mark the pod as not ready, but will not be restarting your pod. Second is liveness probe. Checks if container is alive, of course. Second is restarts if probe fails. If you are, let's say, monitoring your application and you say that if my application is not accessible on port 80, some specific path is not accessible, let's say on port 80, then restart my pod. You can do that using liveness probes. Third is detects unresponsive stuck containers. If your application is stuck somewhere and you know it's irrecoverable, then you would use liveness probe to restart that pod. Runs continuously throughout the pod's life cycle. Like readiness probes, liveness probe stays with your containers throughout its life cycle. Use cases, like we discussed, deadlock detection. Second is unresponsive states. Maybe application is in hung state and you know that it won't recover. Then you will use these probes. Now, I have been saying that application is not accessible. How do you know these things? But what happens is you will configure some timers, and those timers will decide that this probe is failing or this probe is succeeding. So we'll see those things in a while, but I want you to have a high level understanding of all the probes before we jump into the demo section and deep dive further. And third one is memory leaks, apps stuck in out of memory errors. So you know that when an application is stuck there, you will have to restart the application, hence restart the pod to make that application work. We saw in readiness probes that if a pod has multiple containers and one of the container failed the readiness probe, then the entire pod is marked not ready. We saw that. But in liveness probes, it works a little different. If there are multiple containers within a pod and one container failed the liveness probe, only that container is restarted. All other containers part of the pod are left alone. Important distinction between readiness and liveness probe. Then at the very last, we have startup probes. They are used for slow starting apps. You know that my application will take, let's say, 2 minutes to load. in that scenario you can use startup probes. And do not limit yourself to these use cases only, because imagine, let's say, if you remember, we were discussing init containers. In init containers, we used init containers we discussed them in day 21. We said that they run to completion and they run before the main container. So init container, when init container succeeds, only then your main container starts. We discussed this. If I talk about startup probes, let's say in the startup probe you are cloning some data from somewhere, and cloning that data requires at least 1 minute. Then what you can do using startup probes is you can allow this container 1.5 minutes, just adding the buffer to allow this container to start properly, because we know that pods have enough time to start the application. We should ensure that our application have enough time to start. Prevents premature restarts, like we discussed. Restarts if probe fails. So both liveness and startup will restart your containers. RP and LP only run after SP is successful. That makes sense. Once startup probe is successful, slow starting apps we have just discussed, only then readiness and liveness probes come into picture. Only then the timers of liveness and readiness probes become active. So we are discussing timers. We will see this in a while. We know that probing performs health checks of your application. But how can it perform the health checks? How it performs the health checks? What are the probing mechanisms? So we will be discussing probing mechanisms now, and you could be using any of these probing mechanisms. Now, for example, if an application owner comes to you and tells you that this is my application, as long as you know on which port that application listens, you can configure the probes, because the TCP socket probe you see in this example just checks whether a port is open in the container or not. For example, if there were a container here, this probe would be checking that whether port 3306 is accessible or not, and we'll see this one in the demo as well. It just ensures that that port is open. So as long as you know the application port, you can configure readiness probe or liveness probe or startup probe based on the requirement. Again, these are probe agnostic. So if you want to use readiness probe, you can use any of these probing mechanisms. If you want to use liveness probes, you can use any of these probe mechanisms, and same applies to startup probes. In this example, the HTTP GET, that's the first type of probe mechanism. What it will do is it will check whether a path is accessible on a port or not. In this example, a liveness probe is using HTTP GET probe mechanism. It is checking whether /healths API is accessible on port 8080. Similarly, second type is TCP socket. In this container, a readiness probe is being used, and that readiness probe is using the probe mechanism of TCP socket, as it is checking whether this port is open or not. In the third, command execution, we see that there is a liveness probe that is using the command execution probing mechanism, and it is checking whether this file exists in this container or not. Now let's see what are these timers and what will happen. Just a skyby view of these YAML files. This one says that initial delay seconds is 3 seconds. It is saying once the container is in running state, you allow it 3 seconds to settle down, and only then you start the probing. And period seconds, between each probing, keep an interval of 5 seconds. So first probe, wait for 5 seconds, then second probe, wait for 5 seconds, then third probe. And as you know, the probing will continue to happen till the lifetime of that container. So for example, if you have a highly critical application, you might want to bring down this timer from 5 seconds to, let's say, 2 seconds. I'll leave that to you because these decisions are application specific. In this example, the initial delay is of 10 seconds. Maybe this application needs 10 seconds to settle down, and then we are saying probe after every 5 seconds, and once it will start probing, it will check whether the container is listening on port 3306 or not. If it is not listening on that port, it implies that application that was listening on port 3306 is not working properly. Hence, the probing will fail. And since here it is readiness probe, the pod will be taken out of serving client requests and the status of that pod will be not ready. Here we are saying we have a liveness probe, and liveness probe is checking for this file in this container, and initial delay is again of 5 seconds and period seconds is 10 seconds. Now there are certain defaults for these. You might not always want to use them if the defaults work fine for your application, but I have specified these in the example YAML so that you can have a view of the structure. And here we are using liveness probe. If this probe fails, let's say it tries to check and the file does not exist, then liveness probe, as we know, restarts. Hence, this container will be restarted if the probing fails. Now, I also want you to give a glimpse of all the timers that are available. If you go to the GitHub notes of this lecture, you will see that I have added all these timers and whatever we are discussing, and there are plethora of things, and not all of those I can cover in one single video. So in case even if I miss something, I add that in the GitHub notes. So it would be highly beneficial for you to go through the GitHub notes. So these are the timers. There is initial delay, which we have already discussed. The default for that is 0 seconds. Then you have period seconds. We have also discussed this. This is like the interval between each probe. Then there is timeout seconds, maximum wait time for probe response. Then there is a success threshold and also a failure threshold. If it failed once, then don't do anything. If it failed twice, don't do anything. If it failed the third time, then restart that container based on what sort of probing you are using. And then there is a success threshold as well. Once, let's say, the container is back, it should, if it succeeds one probe, then mark it healthy with respect to probes. So we have seen these. Now let's go to the demo section and see how this works in real time. I'll go to my Visual Studio Code. We'll first demo Readiness Probes, which is already open. So what we are doing here is we are creating a pod. We are calling this pod Readiness Probe Demo. It's a BusyBox image that we are using. So to simulate this, what we are saying to the container is touch a file temp/ready and then sleep for 3600 seconds, which is 60 minutes. Then what our Readiness Probe is doing, our Readiness Probe is saying I'll continue to work fine as long as I can cat this file. So since we have created this file here, this file should be available and our probe should succeed. And what we are saying is allow it 5 seconds before you start probing. Period seconds is 5 and the failure threshold is 1. We are saying even if there is one failure, you mark the probe failed. Now understand one thing, in production scenarios, you might not want to be this lenient, because if there is a small deadlock that autocorrects itself, then you might want to tweak this timer. But again, this is application specific, so you will have to discuss this with your application developers and your chief engineer to make the final decision. So we have this file rp.yaml and this is what we are doing. So let's go to our terminal. Firstly, let me delete these pods, kubectl delete pods nginx test. I'll also add a force flag. These are deleted. I'll clear my screen. I'll now write kubectl apply -f and then I want to demo Readiness Probes first. I'll click enter. I'll run kubectl get pod, then our pod should be in running state. It is in running, but the container is not yet running. So as soon as I run it again, the container is also in ready status. So everything looks okay here. Let's do one thing now. If I run kubectl describe pods readiness, I will see that here is the readiness probe that we have defined. We are saying that exec because we are using command execution for probing, because we are catting a file, we are using a command. Then here are the timers as well. I want to show you one more thing. So we have only defined 3 timers, okay? But if I run kubectl get pods readiness probe demo -o YAML, this will give me the YAML output of the running pod. Yeah, you see here all the timers that we discussed right now, all are available here. For things that we did not specify, it has picked the defaults. The default timers have been picked for the timers that we did not define. So this is clear. Now let's do one thing. I'll run kubectl get pods again. Let's simulate a failure, okay? And if we simulate a failure, we delete that file. What should ideally happen is, this container should be in not ready state. So let's go there. I will run kubectl exec -it. I need an integrated terminal. I'm doing this for the readiness probe demo, and then I'll simply run, because it only has one container. I don't have to specify the container. I'll write bin sh to go inside the container. I'm inside the container now. If I do ls in the temp directory, I will see that there is a ready file that exists in the temp directory right now. So what I will do is I'll write rm, then temp, and then I will write ready. So this will delete the ready file. I'll exit this, and now I will run kubectl get pods. You see, it is so quick. This is now 0 because it performed a probe, and the failure threshold that we defined was only 1. So as soon as it failed, it marked the probe as failed, and the container is in not ready state. You can see that here. Now I can run kubectl describe pods. I'll describe this readiness prod, and you will see here a readiness probe failed. Cat can't open temp ready file. Now, as I said, it did not restart the container, which is good, because maybe this file was temporarily gone. Maybe some process was temporary in hung state, and we don't want to restart in such scenarios. So let's do one thing. Let's exec into the container again, and what I will now do is I'll recreate that file. I'll touch temp, and ready was the name of that file. Now that file is available. I exit it. I'll run kubectl get pods, and you see now my pod is in ready state because that file exists, and hence the probing succeeded. So again, I'll go to the describe command and press enter, and I don't see any event here that the pod is ready. Let me run kubectl events to see if there was an event registered there. Oh, I don't see any event for that, but we know from the kubectl get pods output that the container is in running state. The pod is in running state, and this running status implies all the containers are healthy. So let me now clear my screen, and let's do a demo for Liveness Probes now. I'll go to Visual Studio Code again. Here is lp.yaml. I'm using a very interesting image here that was specially designed by Kubernetes to practice Liveness Probes. So what this will do is, I'll quickly show this to you in the documentation itself. What this does is, for the first 10 seconds that the container is alive, /health is accessible. It is accessible because it will return a status, HTTP status of 200. And when you talk about HTTP codes, anything that is between 200 and less than 400 is considered a success, and anything else is considered a failure. So for first 10 seconds, this will be accessible. Then it will return a status of 500, which is unhealthy or not working. So let's go back to our Visual Studio Code and see what is happening here. So this is the image that we are using. We are calling the container liveness. The pod name is Liveness Probe Demo. Argument that they have given is just a liveness. Then the liveness probes start. Again, liveness probe or any probe is defined within a containers. So if you have 5 containers, you can have probes for each of those containers. Then what we are saying is, I want you to access /health on port 8080. If that is accessible, my probing is fine. I'm asking it to have some HTTP headers, and the name of that header is custom header and value is awesome. For example, if you are buying a t-shirt, header is like that. If you have selected size as XL, then that could be a header, size is XL. Or if you are selecting a different language, if I go to a website and I chose English, then my language is equal to English will be my header. So I'm giving you just some examples of how HTTP headers could look like. And we are accessing this on this path, and if it is not accessible, then fail the liveness probe. And we know it will allow a 3 seconds of initial delay, and after that, and we know that this application will fail in 10 seconds. So in 10-15 seconds, we should see that the container is being restarted. And how do we know that? We'll go to the terminal. I'll run kubectl get pods, and like we saw, there is a restarts counter here. This counter will change because we know liveness probe, if fails, will restart your container. I will now run kubectl apply-f. LP is the name of my YAML file. It has created kubectl get pods. I'll run it. It says that the liveness probe demo pod is running. Its age is 5 seconds. Its age is not much, we know that. It's 13 seconds. 1 and 1 is ready. Let's see what happens now. Okay, it is still running. It's been 18 seconds. I'll again press this, and voila, it has restarted 5 seconds ago. We saw that. It is ready, however, it's been restarted, and it will continue to restart it every 15 seconds because that is what the application code is doing. And when an application code is setting that counter like 10 seconds, it should return status as unhealthy, and here we are monitoring that, and the probe is failing every time, every 10 seconds. So hence we see that the container is restarting. Now again, it would have been you see there has been 3 restarts already. So we have a good understanding of both readiness and liveness probes, and we have done the probing mechanisms as well. We have tested this probing mechanism with liveness probes, and we have tested this probing mechanism with readiness probes in our example. Now only TCP socket is left. Let's also practice this by using startup probe. So what I'll now do is, I will go to my Visual Studio Code. I will open the startup probe YAML. This is that YAML, and it's a very simple YAML. I did not find any image that has netcat pre-installed. Now netcat is a utility that you can use to listen on a specific port in your server. For in our example, I'm asking netcat to listen on port 9444. So let's see what this command is doing. First, I'm running an apt update to update my index. I'm using an Ubuntu image here. The next command is app install -y. I'm installing netcat, and as we know, netcat is a utility that can have your server listen on a specific port. And here the port that I am using with netcat, NC stands for netcat, is 9444. And then I am asking my startup probe to use TCP socket probe mechanism to check whether my container is listening on that port or not. I'll go to my terminal. I'll write kubectl apply-f sp.yaml. It says that the startup probe created. I'll write kubectl get pods. Liveness probe is in crash loop back off. Whenever there are multiple restarts and still the application is not working, you would see crash loop back off error. What I'll now do is, I see that the startup probe pod is running and there are no containers running yet. So if the containers are not reporting any status, then you will see the status running. But as soon as the container gives any error, then the status will also change accordingly. I'll press enter. Oh, sorry, get pods, and now I see my startup probe demo pod is running fine. I'll now clear my screen. I want you to understand one thing. We discussed that this is a startup probe. We know one thing for sure. Startup probes only work at the initialization of your container. Once your container is in running state, startup probe will do its job, and only then readiness and liveness probes will start. And once the startup probes are done, they do not run continuously. We saw here that readiness and liveness, they are with the container throughout its life cycle. But startup probes are not like that, and Kubernetes architects have done a very good job in naming these probes. They have named them appropriately. Startup probes will only work at the very start, and similarly init containers, they are initialization containers. So they come, they do their job, and then they go, and then the main container starts. Similarly, once the startup probe has done its job, it will go. And here, as you can see, I've deliberately tried to install a utility, first update the index, then install a utility, and then run a command, because these things can take some time. And in this example, what I am doing is I am telling it to wait for 75 seconds, because failure threshold is 15 seconds and it is polling every 5 seconds. So 15 into 5 is 75. So I am allowing this process 75 seconds to complete. If this process would have not completed in 75 seconds, then the startup probe would have restarted this container. This is defining that I have a slow container which could take 75 seconds to start. If it doesn't start in the stipulated time, then restart the container. I hope you have a solid understanding of all the three kind of probes and you are ready to use them in production environment. All right, that wraps up our deep dive on Kubernetes Health Probes. In the next lesson, we'll look into volumes. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing and subscribing. It will mean a lot to me. Thank you very much.